Hello lecture laners! Today, we'll be looking at trigonometric functions and their derivatives. Hope you enjoy. So the first thing we need to know is how to do the derivative of our sine, cos, and tan functions. Let's start with sine. When you do the derivative of sine x, that just becomes cos x. Nice and simple. When you do the derivative of cos x, that becomes negative sine x. So the way I remember them is that sine x will become cos x becomes negative sine x will become negative cos x, and then we loop back round to the beginning. Now the derivative of tan x is a little bit different. Because tan x is really sine x divided by cos x, we actually have to do quotient rule to find the derivative of tan x. So if we let u equal sine x and v equal cos x, then as we discussed, the derivative of sine x is cos x, and the derivative of cos x is negative sine x. And then we substitute that in. We will get cos squared x minus sine squared x, but because it's negative, that'll become a plus, over v squared, which is cos squared x. And remember, our identities, sine squared x plus cos squared x equals 1. So therefore, this is really 1 on cos squared x, which is just sec squared x. So they're our basic derivatives. Let's look at some practice questions. Let's say I've been asked to find the derivative of cos 2x minus 2 sine x. Well, as we've discussed, cos is going to turn into negative sine. So this turns into negative sine 2x. So whatever's inside the trigonometric function remains the same. But that 2, the 2x, well, we need to do the derivative of whatever's inside the cos and bring that out the front of the function. So the derivative of 2x is 2. So therefore, we bring that out to the front. So the derivative of cos 2x is just minus 2 sine 2x. The next one's relatively easy. Sine x will just become cos x. So therefore our answer is minus 2 sine 2x minus 2 cos x. Moving on to some harder derivatives now. So as we've already discussed, tan x is just going to become sec squared x. Now, because this is cubed, we're going to solve it like a chain rule. So we'll bring the 3 down the front. So it becomes 3 over 3 tan squared x. But then that's going to be times by the derivative of tan x, which is sec squared x. This will then become sec squared x plus tan squared x sec squared x. If we want, we can even take out a factor of sec squared x. And this is actually one of our trigonometric identities. 1 plus tan squared x actually equals sec squared x. So there we'll have sec squared x times sec squared x, which will then be sec to the power of 4x. Let's look at one more. So this one is a quotient rule. So this time I'm going to say u is sine 2x and v is cos x plus 1. That means the derivative of u is 2 cos 2x. So the derivative of any sine becomes cos. Whatever stays in the bracket stays in the bracket. But then we have to do the derivative of what's inside the bracket and bring that out the front. and that becomes 2 cos 2x. The derivative of v will just be negative sine x. Therefore, our derivative will be cos x plus 1 times sine cos 2x minus sine 2x times sine negative sine x over v squared, which will be cos x plus 1 squared. So therefore, this will be 2 cos 2x cos x plus 2 cos 2x plus sine 2x sine x on cos x plus 1 squared. Nice complicated one to finish this off. That's it for the derivatives of trigonometric functions. I hope you have learned a thing or two. Please like and subscribe, and I'll see you in the next video.